Today we are going to do section 4.1, which is fractions. Okay, what is a fraction? For example, let's look at this page, and there is a nice little example here. Okay, here is the fraction 2/3. What does 2/3 mean? That's referring to the shaded part. See that we have a pie here, and the pie is divided into 3 equal parts, and 2 out of the 3 is called 2/3 in fraction form. That means you divide your number is less than 1. Okay, it is exactly how big is it? It is, if you take 1 and cut 1, meaning 1 pie, cut it in 3 pieces, and then take only 2 of the pieces. For example, you can say I ate 2/3 of the pie. Is what you ate right here is all the shady part. Now you can 2/3 isn't the only way you can cut the pie. For example, here's another way of cutting the pie. You can cut the pie. Here's a total of 8 pieces. Now, and let's say you ate 5 of those pieces. Then the amount you ate will be called 5/8, which is yes, it says right here in the book towards a little bit later. Okay, the amount the pie you ate is 5/8. Oops. The amount of pie you ate is 5/8. Now right here, this is not a pie, but the idea applies the same way. Here's a red square is divided into 9 equal chunks. Okay, what is this called? Tic-tac-toe or something? Anyway, it's divided into 9 equal pieces. 2 of those pieces, 2 out of 9 is if the entire 9 piece is considered 1, then just the 2 little pieces is called 2/9, and that is the fraction, the amount of fraction, the fractional value of those 2 things. Okay, out of 9 pieces, we write it as 2/9, and so that, and remember the whole thing is called 1. So this kind of fractions are all less than 1. Okay, 2/9 is quite a bit less than 1, whereas this is 5/8. That's still less than 1, but more than a half. Okay, because half of this thing will be 4/8, and so on. So that's that. Okay, let's look at the next page, which they want you to shade something. What is 3/4 of a circle? So if you are given a circle and you have to shade 3/4 of it, then we'll cut the circle into 4 equal parts and then shade 3 pieces, and that will be 3/4. And remember, the whole circle is called 1, so 3/4 is less than 1. And then so next, let's look at the next page. I'm now at page 257. Now on this page we have some explanation of what a fraction means. Now this whole bar right here is called 1. Okay, we'll consider that as 1. And then if you cut it in half, then each half is 1/2, also called 1/2. Okay, and that's just how it's pronounced in English. And so half of this is 1. This thing will be called 1/2. And this thing is called 1/3 or 1/3, because that's the same piece cut into equal chunks, 3 equal chunks. So each chunk is called 1/3. And then if the same piece is cut into 4 equal chunks, each piece will be called 1/4 or 1/4, and so on. This is cutting everything into 6 pieces. Cutting the whole thing into 6 equal pieces, then each piece is called 1/6 or 1/6. But anyway, so as a result, as you can see here, then two of the halves will make a whole. Okay, 3 of the thirds will make a whole. Whole means 1. Okay, this is the whole, means 1. And then 4 of the quarters will make a whole right there. And then 6 of the 1/6 will make a whole. So however many pieces that you cut it into, then you need just as many pieces to make the whole thing again. So let's well, as a result, okay, let's look at the bottom of the page. We're looking at example 4.3. Now we have how do you make a whole? As I mentioned before, 4/4 it will make a whole, because a whole means 1, okay? And then if you cut something into 4 pieces and then there's 4 of them, that will mean 1. Similarly, 5/5 will be 1, okay? Because you cut it into 5 chunks and then you got all 5. So that means you have 1 whole pie. And similar for 6/6. So next, let's look at page 248, which is the following page, and look at example 4.4, the next example. Now, what happens when you have, the example wants you to come up with 3 halves. Okay, here it is. Let me make it a little bigger. There, that's a little better. Okay, what happens when you have 3 halves? So we have, when you have 3 halves, you have 1 half, 2 half, that makes a whole, and then you have another half. So you have a whole one and then a half. And what if you had 8/5? Now, if you have 8/5, well, 5 of the fifths will make a whole pie, and then you will have 3 of the fifths. So you will have 1 plus 3 and 3 in fifths. Next, the question is, what are we doing? 7/3. So you have 7 of them, 7 of the third pieces of pie. Okay, so the broken pieces, if you put them, 3 of them make a whole pie. So you have 1 pie, 2 pie, that takes 6 pieces. And then you have 1 more pie. So you have 2 and 1/3 of pieces of pie if you have 7/3 of pie. And then so that is that. And so that when that happens, when we just said when you have a whole number and a fraction to put together, then it is called a mixed number. And the fraction is called a proper fraction if it doesn't have a whole number included in it. It's called an improper fraction if it's bigger than if it actually contains a whole number. For example, well, we'll look at an example soon enough. Okay, that is for example. Next, let's look at example 4.5 on the following page. We have this thing right here, and the fraction is improper only because there's more chunks than there's pie. Okay, that is, you have more than the whole piece. Excuse me, I shouldn't have touched the microphone. And so if you have more than that, more than the whole piece, that's called improper fraction. Now in this case, this will be called 4/3 because your pie is being cut into thirds, but you have more than 1. So that's 4/3, and that would be improper. On the other hand, well, anyway, if you don't have more than 1, that 1 pie, 1 whole pie, you only have part of a pie, that fraction is called proper or something. Doesn't matter. And what it's called is just a fraction. Okay, so let's look at this. Example 4.5, by the way, this is called 1 and 1/3 because this is 1 whole pie and this is 1/3 of a pie. So together, it's also called 4/3. Okay, right here. So this is because you have 4 pies, 4 pieces total, and each piece is 1/3. So it's called 4/3, which is the same as 1 and 1/3. So let's look at the next example. Okay, now for example 4.6, what is 11/8? 11/8 means your pie is being cut into 8 pieces, and you have 11 pieces of the cut pies. Okay, maybe you're eating a bit much. So what happens is being that your pie is cut into 8 pieces, 8 of them makes 1 pie. So 8 means 1. 8 pieces means 1. And then being that you're only 11 pieces, so you have 3 more pieces left. So total, what you have is 1 3/8 of pie. Okay, that means you have a whole pie plus 3 out of 8 slices of the whole pie. So that is that's that. Okay, now normally when next, let's look at example 4.7. Now, if you have, say, 11/6, okay, that's a fraction where you have 11 pieces of pie. Each piece is a 1/6 of a pie. So if you write it as a mixed number, then you notice that, well, 6 of them will make a whole pie. So you have 1 here. And then what's left will be 11 minus 6. So you have 5 pieces of pie left. So what's left is 5/6. So your answer will be 11/6 right here, okay, is the same as 1 and 5/6. That's how that's pronounced. Yeah, okay, it says so right here, but it's, and anyway, so that is that. Let's look at the next example, which is now we're going to do it opposite. Now we have this mixed number. We have 1 and 4/5 of a pie. Now if you write it as just how many slices are there, then here's 1. Okay, the pie is cut into 5 pieces, and then you have a whole pie plus 4 pieces of the pie. So you have 1 and 4/5. Now how many is that total? That's 5 plus 4 is 9. So you have a total of 9/5. So that is so the 1 turns into 5/5, okay? And 5/5 plus 4/5 gives you 9/5. So the result is you have 9 pieces of the pie that got cut into fifths. Okay, now so how do you convert anything into a mixed number? Next, let's look at example 4.9. To convert this thing into a mixed number, then you calculate this. First, there's a 6 there. So what you do is see how many 6s that goes into 11. Well, there's only 1, okay, and then you will have 5 left over, as we mentioned earlier, and therefore the total number, the fraction can be turned into a mixed number will be 1 and 5/6, which is also what is said down here. Okay, so what you're gonna do is that you're gonna do division. 11 divided by 6, that's just 1, because there's and then you have 5 left over. So then that is how you convert a number in a fraction into a mixed number. You do division, and then you see what's left over. All right, so next, let's see, we do another example to pound the concept in. Let's look at, now we're on page 262. So we're now on page 262, where we're looking at example 4.10, where we're supposed to convert the improper fraction into a mixed number. Now what is 33 divided by 33/8 is our fraction. Okay, the fraction is the same as division. The fraction line is also called division line because you're doing the same thing. So how many times, that is, what is 33 divided by 8? Well, the biggest number you can come up with would be 4 times 8. Okay, will give you 42. So 33 divided by 8 will be 4, which gives us 32, and then which means the remainder is 1. So we have 4 and then 1/8, because that means 33. If you have a pie that's divided into 8 pieces each, and you got 33 pieces, which means you actually have your own 4 whole pies. Okay, that's account for 32 of the pieces, and then an extra piece that is the 1/8 of the pie. So that is how the improper fraction is turned into the mixed number. This thing is called the improper fraction. That thing's called the mixed number. So, and yeah, that is that. Next, let's look at example 4.11 at the bottom of the page, where we do the opposite. Okay, we have a mixed number and we need to turn it into an improper fraction. Well, your pie is cut into 3 pieces each, and you own 4 pie plus 2 slices. So the total will be, you have the total of 12 pieces, right, of pie, plus the 2 extra pieces. So you have 14 pieces total. So the answer will be 14/3, which is what that says on the following page as well. Okay, in general, in order to find out, convert a mixed number to an improper function, what you do is you take the whole number, multiply by the denominator, and then add to this thing. 4 times 8 is 32, and then plus 1 is 33. Similarly, in this case, we'll do 4 times 3 is 12, plus 2 is 14. So that's why the answer is 14/3. In other words, you're counting how many pieces you have total, and then that's the number, that's the numerator, which is the number on top is called the numerator, and then the number on the bottom is the denominator, which tells you how many slices you're cutting each pie into. So that is that's that. Okay, the next one is the next example, the same thing. Okay, example 4.12, where we are converting the mixed number into an improper fraction. Now in this case, your pie is being cut into 7 pieces each, okay, and you own 10 pies plus 2 more slices. So how many pieces are there total? You will take 10 times 7, which gives you 70, and then plus 2, which is 72. And that is the total amount of pie pieces that you have. So the answer will be 72/7. Okay, that is the fraction, which is, if you look at the next page, exactly what it says. Okay, 72/7. And because you're just counting how many pieces you got total, if it's cut in that specific way. So next, let's see. And let's look at the following page, 265, where I'm looking at example 4.13. So example 4.13 asks you how many eighths equal to 1/2. That means, let's say you have one whole strip here. This whole length is called 1. So cutting it in half, each one is a half. And then if you cut it some more, so these are called the 1/8. Okay, so how many eighths make 1/2? If you look at it, count, that will be 1, 2, 3, 4, and that is that's that. And so please do part B and C yourself, okay, by looking at the pictures and figure that out. So that is that's that. And then we are going to look at the next page. Now there is right now I am on page 266, where we talk about equivalent fractions. Now this is 1/2, right? Because the pie is being cut into 2, so this is 1/2, or 1/2. And now this is the pie being cut into 8 pieces, and there you have 4 pieces left. So this is 4/8. And as you notice, 4/8 and 1/2 are exactly the same amount of pie. It just got cut more, but the amount hasn't changed. That's why 1/2 and 4/8 are the same value. And the way we can tell there's the same value is that if you take 1/2 times, if you multiply by the same number top and bottom in the fraction, okay, so you multiply it by 4, then it will equal to the same thing. What you're doing here when you multiply something by 4 like that is you're taking the original and cut it some more. Okay, but you haven't increased the amount. You just slice some more times, and then the whole thing falls apart. I mean the pie does. And so any time with a fraction, if you multiply the numerator and the denominator of the fraction, okay, that is, if you multiply the top number and the bottom number by the same number, okay, say A over B, if you multiply both numbers by C, you will get the same fraction back. That doesn't change anything. All right, so to illustrate the point, let's look at example 4.14, okay, on the same page, going down a little bit. So let's make up 3 fractions that's the same as 2/5. So we can multiply top and bottom by any number you want, okay? Let's say multiply it by 2. And then if you multiply by 2, then 2/5, then you find out that equals to 4/10, because you cut it some more. And 2/5 is also equal to 6/15. That means if you take 2 out of 5, is the same as 4 out of 10. If you cut your pie into 10 pieces and eat 4 pieces, that's the same as cutting your pie into 5 pieces and eating 2 pieces. And then if you cut it into more, is the same as 10 over 25. So what that means is 4/10 and 6/15 and 10/25 are all the same as 2/5. They're not just equivalent, they're equal. okay, the exact equal amount. Well, the only difference is your pie got cut more, but we don't care how much your pie got cut. We only care how much is there. Okay, so if you eat 2 pieces of pie that was cut into 5 even pieces, then you ate just as much pie, no more no less than if you ate 4 pieces of pie that got the same pie that got cut into 10 pieces, that sort of thing. So let's go to the next page. Find a fraction with a denominator of 21 that's equivalent to 2/7. Okay, now it has the number on the bottom is called the denominator. The number on top is called the numerator. We need a fraction whose denominator is 21, and what is the top? Well, we will let's write that down. Okay, the fractions. Let's see. We need a fraction that's the same as 2/7, like this. But at the bottom is 21. So what is the top number to make it these two the same thing? Well, we need to figure out 7 times what number equal to 21, and then we'll take that number and multiply by 2. That will give us, because if you multiply a fraction by the same number, top and bottom, you will get the same fraction. So 7 times what equal to 21? Well, that will be 3. So if we multiply by 3, top and bottom, okay, then 2 times 3 will be 6. So these fractions will be equivalent because they are the result of the old fraction multiplying by the same thing, top and bottom. So that gets that. All right. So next, let's look at the number line. Okay, the number line is representing numbers on the line, and the number line we can start at 0 because right now we're doing just the positive numbers, so we only start at 0. Then it goes 1, 2, 3, 4, 5, and all evenly spaced. Okay, so then that represents the numbers. And now, if that is the case, where are these things? Right there. There's a big pack of junk there, right? And 1/5 will be is less than 1. Imagine 1 being cut into 5 pieces, and you already got 1, so it's about over here. Okay, 4/5 is closer to 1 right here. 3 is here. What about 3 1/3? I'll be a third over, maybe about here. And maybe I should use something else to point at. Give me a second here. Let me get this thing out. Okay, here's a pointing object. Okay, so 3 1/3 is I'd say right about here. Okay, and 7/4. What is 7/4? 7/4 is 1 3/4. Okay, if you can count how many fourths are in 7, there is only one pack of. You have 1 pie here and then 3 slices, right? For this number. So this number is 1 3/4. 1 3/4 will be less than 2, more than 1, about right, I'd say about here. Okay, and then what about 9/2? 9/2 is 2 goes into 9 4 times. Okay, that becomes 8. So 4 times. So this number is 4 1/2 right here. 4 1/2 would be, and then 5 is just here, and then 8/3. 8 goes to 3 goes into 8 2 times, so is it back here? But it will have leftover of 2/3. So right around here, that should be it. All right. So please work on the number line a little bit to get used to it, and look at this example. Actually, this isn't even an example. Well, this is on page 267 anyway. But that is the number line. Okay. So we just did the number line on the positive side, and let's look at example 4.16. Actually, please read example 4.16 on the following page yourself, okay, and figure out where those points are. And your book does give a very detailed explanation to look for them if you have any problems. And let's see. So that's example 4.16. And next, example 4.17. Let's see, 4.16, yeah, what's down there? Okay, negative numbers, right. Example 4.17. Now what happens when we have, now we're going to deal with negative fractions. So let's look at example 4.17 on page, this is 269. All right, so example 4.17, we have a bunch of stuff, and I want to specify the negative numbers. Let me make it somewhat bigger. Maybe not too big. Let me see. And remember that the bigger than and smaller than sign, the pointy side represents the small side and the wide side represents the big side. Same here. So this is the smaller than symbol, okay? And whereas this is the bigger than symbol, because the big side is on over here is bigger than the other side, which is the pointy side is the smaller one. So please do example 4.18 yourself carefully. And the only thing hard about this is sometimes you might make a mistake and then mess up. And then the bigger than, smaller than, and all that stuff. Otherwise, there is nothing unusually difficult about it, I don't think. That is, as long as you're careful about assigning where the negative numbers are, okay? Everything on the left side is less than everything on the right side, is how that works. But you can, yeah. Anyways, and also, if 1 is less than 2, then 2 is bigger than 1. So if you're supposed to compare, then if it says 1 less than 2, you can also say it as 2 bigger than 1, same thing. So anyway, please do example 4.18 yourself. And with that, we have come to the end of this section. Right. So for homework, which is on page 271, please do problems 19, 29, 35, 39, 43, 45, 49, 63, 65, 67, 69, and 71. And that marks the end of this section.